Hello students, welcome to the fourth part of our lesson Whole Numbers. In our previous lessons, we have learned about the whole numbers, addition, subtraction and multiplication of whole numbers and their properties. Now in this lesson, we are going to learn about the division of whole numbers and its properties. So let's see what we are going to study in this session. So in this session, we will study the division algorithm, properties of division of whole numbers, patterns in whole numbers, and then it would be followed by the exercise. Division algorithm. Children, we have already learned about division in our lower classes. So let's have a revision. Division is the inverse process of multiplication. Sometimes division is also termed as repeated subtraction. Just as we call multiplication as repeated addition, division is termed as the repeated subtraction. Now let's revise few terms related to division. First is dividend. The number which is to be divided is called dividend. Then divisor. The number by which dividend is divided is called the divisor. Then quotient. The number of times the divisor is contained in the dividend is called the quotient. Or in simpler words, I can say the answer of division is known as the quotient. Now the next term is remainder. The leftover number after division is called the remainder. So you must be remembering while performing division many a times the dividend does not get completely divided by divisor and some number is left over. So this leftover number is known as the remainder. Now let's see what is division algorithm. So according to division algorithm, dividend is equals to divisor multiplied by quotient plus remainder. So this is known as division algorithm. Many a times we use this division algorithm to check our division. Whether we have performed correct division or not, this can be checked by using division algorithm. So if I multiply divisor by quotient and add remainder to it, it should be equal to dividend. If it doesn't comes equal to the dividend, then our division is wrong. Now let's see the properties of division of whole number. So the first property is the closure property. It says when a whole number is divided by another whole number, then the quotient is not always a whole number. Or I can say whole numbers are not closed for division. For example, if I divide 14 by 2, then the quotient will be 7. But if I try to perform 5 divided by 3, then the quotient is not a whole number. The answer will be in the form of a fraction or we can write it in terms of decimal. But the answer is not a whole number. So we can say that division is not closed for whole numbers. Now the next property is the commutative property. So for any whole numbers a and b, a divided by b is not equal to b divided by a. Or in other words, I can say a change in order of division of two whole numbers changes the quotient. That means if I interchange the dividend and divisor, the quotient will not be same. It will change. Let's see it with the help of an example. So if I write 10 divided by 2, then quotient is 5. But if I write 2 divided by 10, I have interchanged the divisor and the dividend. The answer is again not a whole number. It is a fraction or a decimal. So that's why we can say division of whole numbers is not commutative. Let's see few more properties of division. So the third property is the associative property. It says for any three whole numbers a, b and c, a divided by b and then divided by c is not equal to a divided by the quotient of b divided by c. That means the grouping, if I change the grouping in division, the answer doesn't remain same. Let's see it with the help of an example. Say I take three whole numbers, a is equals to 10, b is equals to 5 and c is equals to 2. Now if I write a divided by b, that is 10 divided by 5 divided by the third number c. So now here, since this is written in brackets, we solve it first. So 10 divided by 5 gives me 2 and 2 divided by 2, the quotient is 1. Now if I change the grouping, 10 divided by 5 divided by 2 in the bracket. This means I have to first divide 5 by 2. Now if I try to divide 5 by 2, the answer is not a whole number. So again I cannot divide it by 10. So whatever is the answer, it will not be a whole number. Or simply I can say it won't be equal to the number 1. Thus I can say a change in grouping of three whole numbers while dividing changes the quotient. So this is the associative property of division. Now let's see few more properties. The next property says when a whole number is divided by itself, then the quotient is 1. And when a whole number is divided by 1, the quotient is the number itself. For example, if I divide a whole number 13 by itself, that is 13 divided by 13, then quotient will be 1. And if I divide 13 by 1, then quotient will be 13. Now next property is about the 0. When 0 is divided by any whole number, the quotient is 0. And when a whole number is divided by 0, the quotient is not defined. Now what does it mean? If I divide 0 by any whole number, the answer is always be 0. Whereas I cannot divide any number by 0 because division by 0 is not defined. We cannot get an answer if I try to divide any number by 0. So that's why we say division by 0 is not defined. Now let's see few problems based on division. Example 1. Find the greatest 5-digit number which is exactly divisible by the greatest 2-digit number. Now to solve such problems, we know the greatest 5-digit number is 99,999 and the greatest 2-digit number is 99. So we divide 99,999 by 99. So when we divide, what we get? So 99 ones are 99 When we subtract, nothing is left. I bring down 1 9. So it is not divisible. So I put a 0. Then I bring down the next 9. Again it becomes 99. So 99 ones are 99. Then bring down this 9. It's not divisible. So write a 0 here. And then remainder is 9. So we will get quotient as 1010 and remainder as 9. That means the greatest 5-digit number 99,999 is not exactly divisible by 99. Now to find a number which is exactly divisible by 99, what we do? We subtract the remainder from the highest 5-digit number. So subtracting this, I will get 99,990, and this is the greatest 5-digit number which is exactly divisible by 99. So for all such problems, you have to first divide the number, and whatever is the remainder, subtract it from the given number. In this way you will get the greatest number which is exactly divisible. Now let's see one more example. Example 2. The number 6257 when divided by 43 gives the remainder 22. Find the quotient. Now in this problem we are going to use the division algorithm. Now it's given dividend is 6257. Divisor is 43 and remainder is 23. And I don't know what is the quotient. Now let's write the division algorithm which we have seen. Dividend is equals to divisor multiplied by quotient plus remainder. Now we've put the values which are given to us. Dividend is 6257. So in place of dividend I write 6257. Divisor is 43. Quotient is not known to me, so I write quotient as it is, and remainder is 22. Now since I have to find quotient, I write it separately. So 43 multiplied by quotient is equals to 6257 minus 22. So we have learned that when we change the sides, this plus on one side goes as minus on the other side. That's why we write here as minus 22. So 6257 minus 22 gives me 6235. And here this 43 is in multiplication with quotient. So I write it in the division. So quotient is equals to 6235 divided by 43. So when I will divide 6235 by 43, I will get an answer 145. Thus, the required quotient is 145. So in this way, in such problems, you have to use the division algorithm and then substitute the values and find whatever number is not given. So after learned about various operations on whole numbers, let's see some patterns in whole numbers. Now let's revise what is a pattern. So pattern is a sequence of numbers or picture which follow a certain rule. So generally whole numbers follow certain patterns. We can arrange numbers in elementary shapes consisting of dots. So we can represent the numbers using dots. For example, every number can be arranged as a line. For example, if I write number 1, then it can be represented as single dot. Number 2 can be written as two dots in a line. Number 3 as 3 dots in a line, and so on. We can write any number in form of dots in a line. So every whole number can be arranged as a line. Now there are few numbers like 3, 6 and 10 which can be arranged in the form of a triangle. Such numbers are known as triangular numbers. So all the numbers cannot be represented as triangle. Only few can be represented. So let's see how 3 can be written. 3, if I want to represent 3, I can write it in this way. 1, 2, 3. Similarly, 6 can be represented with a triangle like this. 1, 2, 3, 4, 5 and 6. So in the same way, we can represent 10 as a triangle. Next triangular number will be 15. So to obtain the triangular number, you simply add one number next to it. So we have seen that there are certain numbers which can be written in the form of shape triangle. Now there are certain numbers like 4, 9, 16 which can be arranged in the form of a square. So these numbers are known as square numbers. So to represent 4, we can represent it using dots in this way. 1, 2, 3, 4. Similarly, 9 can be represented in form of a square. 16 can also be represented in the form of square. So basically, square numbers can be obtained by multiplying a number to itself. Say 4, it is, if I multiply 2 by 2, then I will get 4. 3 multiplied by 3 gives 9. 4 multiplied by 4 is 16. So the next square number will be 5 multiplied by 5, that is 25. Now some numbers like 6, 8, 10, they can be arranged in the form of a rectangle. So we can call them rectangular numbers. So generally all the even numbers can be represented in form of rectangle. So it's like this, I can write 6 as 1, 2, 3, 4, 5, 6. Similarly, I can write 8 in the form of a rectangle. 10 can also be represented in the form of rectangle. So all the even numbers can be represented in the form of rectangle. Now let's see some examples of patterns in whole number. So example 1. Study the pattern and write the next two steps. So in this pattern, 1 multiplied by 8 plus 1 is equals to 9. In the next step, we have 12, that is 1, 2 multiplied by 8 plus 2 is equals to 9, 8, 98. Now in the next step, we have 1, 2, 3. So we are adding one digit at a time, multiplying it by 8 and then adding the same digit by it. So I will get the answer is 987. So here also you can see a pattern. First the answer was 9. In the second case the answer was 9, 8. Now here we have 9, 8, 7. So we are writing the digits in the decreasing order. So let's see the next step. Now I am adding the fourth digit, that is 4. 1, 2, 3, 4 multiplying by 8. Now add the same digit whatever is added. So 4, here also I add 4. So the answer will be 9, 8, 7 and 6. So in the same way, if I add 5 in this number and then add 5 here, the answer will be 98765. So in the same way I can write the next step. So in the next step, what will be the answer? I have to add one more digit. So it will be 1, 2, 3, 4, 5, 6 multiplied by 8. Then plus the same digit, that is 6. So plus 6. Now here we have to add one more digit in the decreasing order. 9, 8, 7, 6, 5, 4. And the same way here I am adding 7, and in the answer 3 will be added. So you can verify it by doing simple calculation, but there are certain patterns. Following these patterns, we can write the complicated multiplication problems. So children, today we have learned about the division of whole numbers and the word problems based on it, and we have also seen some patterns in number. So on the basis of the knowledge which we have gained in this session, I hope you would be able to solve the given exercise. So that's all for today's session. Thank you, children.